Database Basics. This is the Boston MySQL user group. It is Monday, February 11th. And I'm on MySQL DBA, www.sherry.com, alphabetgmail.com. My company's Pythian. Their logo's at the bottom of the slides. And eventually, here we go. So, why use a database? We're going to go over that. This is what we're going to do. This is my agenda. We know over the ER model, which is entity relationship. We're going to go over create syntax. We're going to talk about a catalog of 1,000 movies. First, we're going to talk about why would we use a database. So if we want to catalog 1,000 movies, why would we use a database as opposed to like a flat file? Anyone, Bueller, anyone?
Faster searches.
Faster searches, okay. I mean, if I catalog 1,000 movies on my shelf just by cataloging them, by putting them in alphabetical order by title, or how the movie rental place does it, right? That's great, but you can only search on title. You can't really search on actor, right? You can only really search one way. Same thing if it's in a flat file text, right? You can grep for things, or you can maybe search through the text or whatever, but really they're ordered in one way, and that's pretty much it. And any other search is kind of not so well. If it's in the middle of a huge file, 1,000 movies, that's probably not so much text. But if you put in, 1,000,000 movies or 5 million movies or, every movie that's out there, I don't know how many IMDb has in there, that's going to be megabytes and megabytes of text. So searching through that is going to take a long time. Searching for all the movies with certain actors or all the movies made in a certain year, all the movies in a certain genre, it's going to take you a while. So when we're gonna talk about cataloging 1,000 movies during this time that we have here today, also called workshop or whatever, and we're gonna talk about movie details. So some of the movie details are like their genre, are they a horror film or a children's film? Who's the starring actors? What the plot synopsis is? The DVD extras, things like that. So let's get a little more specific. What do we care about? When I say movie details, okay, we have starring actors. Okay, that's one of the things we care about is actors. What are some of the details we care about, and what are some of the details we probably don't care about when we're just making a movie thing? Category, okay. We care about category. I'm just going to write them here. So category, actors, what else?
Running time.
Running time, okay.
Year released.
Year released.
Rating, maybe?
Rating? Rating like PG-13 rating?
Yeah.
Okay, so I'm going to call it the MPAA rating. The Motion Picture Association of America rating.
You might want to throw in directors.
Okay, directors. Actually, I'm going to say we don't care about the directors. We're not that much of movie buffs. This is just our personal collection or whatever.
Personal
If
rating.
you're going to use the board, can you put the lights on?
I'm just putting it for my notes so that if you guys
Okay.
say something again. That's pretty good. Because it's our personal things, I would put also like cost. And, the title, which was so obvious that we didn't think about it. So here's what I'm going to just say that we're going to put. So somebody did say my rating, and I said I'm not going to worry about my rating, right? I'm not going to worry about when I bought it or what studio did it or the UPC code or the format, like is it DVD or VHS. I don't care about when I viewed it, who I saw it with, because if you first saw Jaws in 1990, maybe you care about that. I don't care about that detail. Did I write a review about it? What shelf is it on in my house? I'm saying for the purpose of this example, I don't care about it. Recommendations and then related movies, which that's a whole other thing that I don't want to get into, but we are going to include title, description, little description, plot synopsis, whatever. Category, actors, release year, original language, the language it's currently in, so if I bought a French movie but it's dubbed in English, the length of the movie, the cost of the movie, the MPAA rating, which, PG-13, whatever, and then any DVD extras, like if it's the director's cut or if there's commentary. So, I don't know how well you can see that, but basically what I first did was made a spreadsheet because that's how we all start. when we're doing these things. We start with a spreadsheet because it kind of looks like it, right? We have a title, we have a category, we have a year released, we have a language, we have original language, we have the length, that's in minutes, we have the cost, the MPA rating, special features, all that stuff, description. Now, if any of you are familiar with the Sequila database, then this is all going to look familiar. So this is the test database that you can download to work with MySQL. It's called Sequila. Sequila is the name of the dolphin, the little MySQL logo. It's a little MySQL trivia there. But that's why they're such actors as Groucho Sinatra, and titles such as Frisco Forest, because it's just really, it's not trying to override anybody's copyright. It's just trying to have some realistic things with some real data that's mixed up. So we already talked about why we wouldn't want this particularly. Sure, we can sort, on the title. We can sort on, the year released if we wanted to find all the year released. But what else is not so great about this format? Yeah?
You have to put all the information in one sheet.
You have to put all the information on one sheet, okay. What happens if Groucho Sinatra gets married to an uber high feminist and wants to hyphenate his name to match hers?
You gotta go and change it in every row on the sheet.
Exactly. Luckily we have computers so we can do like Control H, search and replace everywhere, but there's redundant data in here, and it could be inconsistent if we don't do things properly. So flat files are not optimal. There's data redundancy. There could be inconsistency. There's no way to make a spreadsheet fill in all the columns. So if I decide not to fill in an actor column, it doesn't matter. There's no way to force me to do that on a spreadsheet. I mean, you can make a macro or whatever, but you could get a partial list, and then there are integrity constraints. If I realize that this movie didn't actually ever come out. Club Graffiti isn't really a real movie. It was just test data that somebody put in my spreadsheet. If I just delete the title and don't delete the whole row, I now don't have any integrity constraints. And again, it's really hard to say, okay, take out all the movies that Groucho Sinatra was in. All the studios have now said, well, he's not a starring actor. We don't like him anymore. So take him out of all the starring actor lists or whatever. We can't really do that easily. So here's another thing, another reason they're not optimal. Concurrent access. Now I said this is my personal movie collection, but if my family wants to see, what DVDs we could watch tonight or whatever, maybe they want concurrent access. Maybe we just went shopping to, for your entertainment. We're just Christmas. We got a whole lot of things for Christmas, and everybody wants to update it at once. There's no concurrent access. There's no security other than whatever security you put on the file itself, and there's no atomicity if you have more than one file. So meaning that you can't change, again, we were talking about having Groucho Sinatra changing his name. You can't have that go at the same time for everything, and especially not with more than one file. Even if I say, okay, search and replace globally, it's going to replace one and then replace another and replace another. And since I have Windows, if it crashes in the middle, what's going to happen? It's going to be inconsistent. Half of them are going to be auto-saved, recovery. I'll get it, and half of the entries will be changed and half won't. And you get this especially more with more than one file. So again, not the world's best example, but y'all use databases, so y'all know why you would use a database. So I'm going to talk about the entity relationship model. And when I talk about it, I'm going to talk about an entity set. It's going to be a rectangle. And we can talk about what an entity set is a little later. Right now it's just a thing. You could think of it as an object, but I don't want to call it that because there's also object relational mapping. And I don't want people to think that that's similar, because I don't want people to say, okay, well, an entity is just a table or an entity is just an object. That's not the way it is at all. It's more of a real-life object thing than a relation might be. But you can translate into, once you've developed all your entities and attributes and relationships, you can develop it into a model for a relational table. So there are attributes, which are properties of an entity. For instance, if an entity is a person, an attribute might be like hair color. right? If an entity is a movie, an attribute might be the title. So there are simple ones, there's also composite ones. And there's also, you can have a single attribute or multi-attribute. So you can have more than one actor. And then you can have a composite attribute, like my name might be an attribute of me, but my name is made up of my first name and my last name and my middle name. So that's a composite attribute. And then relationships are in diamonds. All right, can you see all the lines there? It'd be better if that wasn't in black, huh? Actor has has lines to first and last, and then movie has one line to each and every single one. So here's our basic movie ER diagram. We have a movie. That's our entity. It's in a rectangle. Everything else is a circle, and it's in an ellipsis. It's an oval. So the description of the movie, over here. My pointer. Give me my pointer. Please. There we go. The description is an attribute. The category, I don't know if you can see, there's actually two ovals around here in the category because there can be more than one category, right? It could be a children's film, but also, I was going to say horror, but probably not horror. But it could be a drama, or a comedy, but also a children's film. It could be animated and comedy, or animated and drama. So then we also have title. The feature is the DVD feature, so it could have commentary and it could be the director's cut. The MPA rating, there's only one. The actors in it, there can be more than one. So again, a multi-set is two circles around it. Not that you can see the circle, so it doesn't really matter, but there you go. And then the actor itself is a composite, has composite attribute. So you see at the bottom here it says find composite attributes and multi-valued attributes. I'm just telling you what they are. So if you're wondering why I was doing this long and involved thing. So an actor this is a composite attribute. It's got an actor and first and last name. And then we've got the cost and the length and the language and the original language and the year released, and those are all single attributes. That are simple single attributes. Any questions? Great. So, is there anything wrong with this diagram? Or is there anything that can be done better? It doesn't have to necessarily be wrong. But can anyone see anything that might be bad about it? Alright, super. Well, guess what? I did. Because I made it. It has the same issues as the spreadsheet does. The redundant attributes may be entities, right? So here's the category as an attribute on the left-hand side, right? But if I decide that I want to change animation to animated, now I have to do it in every single row, whereas if it was its own entity, its own thing, it could actually have, now we have this relationship between movie and category. A movie is classified as a category, and a category has as an attribute a name, right? The name of the category is animated, right? The title of the movie is, Frisco Forest. So this is actually a really, really important slide because there's no one right way to do an ER diagram. So I said what's wrong with this, maybe that's not really fair. But given how we're using things, does it make sense to have category as an entity or a category as an attribute? And it really, really depends. So I just want people to make sure, people know that, I'm not saying that the category as entity is always the right way to go. But in this particular case, we want that. And I'm sure you can see that with actors too, which is probably my next one. Oh, here's the better one. Better movie ER diagram. So, yeah, I have the actor over there. I should have gotten a laser pointer, huh? Actually, I have one. I'm so smart. I wish I had $100.
Tom's got one.
Oh, Tom's got one. Oh, thank you. Tom's so great. Thank you, Tom. Everyone should thank Tom because Tom actually gets us this room. So, and Tom, do you need any lessons? Did anybody ask Warm in here?
Can't do anything about the temperature.
Oh, okay. Sorry about that, guys. So,
Open the window?
I think whatever. Anyway, we'll play strip MySQL, or as my husband calls it, it's my sexual, because that's the way he is. So we have actors here, and an actor is an entity, and the attributes of the entity are first and last. So now what we have is we have an actor stars in a movie, right? The movie has a stars actor. So this is now the relationship between actor and movie. And if we ever decided that we wanted, who's the president of their fan club or whatever, we can now put that as an attribute of actor. So now their first name, their last name. Groucho wants to change his last name. He got married to Stella Marks, and so now he's going to change it to Groucho Marx. And so now he can change his last name, and then we don't have to worry about updating every single movie. We update one entry. We update the one actor entry. That's him. And it's still associated with the same movies. Similarly, we have the category. We have movies classified as category. And we actually have languages, right? Now, this is something that is also interesting because we had original language and the current language. So if I had a movie that I'm watching and it's in English, but it was originally in French and it's dubbed, right? The languages are the same. English is the same. American English is the same as, American, like ENUS, right? FR is French, right? So however we decided to represent language, and I didn't actually put any attributes of language, but I would probably have like a name of the language, or I might have the name of the language in the country it's spoken in, because English in the UK is different from English in the US. So I don't actually have that here because, as you can see, the diagram got pretty big. But you can imagine that, off over here, there's a little, line to a circle, and inside the circle, it says country, and there's another one. But there's still some things like, rating, feature, again, title, description, year released. Those still are attributes. Now, could we make rating an entity in and of itself? Sure, if the Motion Picture Association of America decides that, now it's not rated X, it's rated NC-17, which they've done, right? They've changed the ratings. Now we would have to go through every movie and change the whatever. But, again, there's no one right year diagram. We could do it with year released, right? But that's kind of silly. You're never going to change a year, right? But you might have, in a different application, you might have a need to actually just reference the year because you don't want the redundant data. Maybe it's a lot of data. Maybe it's not the year. Maybe it's, somebody's, a date or something that would be a lot bigger than just representing the year.
Star Wars original release renewed.
Yeah, exactly. George Lucas went back in time and changed stuff. So yeah, I pointed that out already. So now, it's only now that we're ready to create tables, right? And you're going, oh my God, it's 7:30. We've been talking a half an hour. We haven't even created a table yet. We haven't done anything. Well, we've done a lot. So for now, I'm going to just say one table per entity. Now, I said before that you don't have to think that there's, one entity per table kind of thing. But first, you have to talk about the data types. Chapter 9 of the MySQL 5.0 manual is data types. I'll bring that up now because if I was smart, I would have had that prepared. But I'm not, so I didn't. And this is just things like, do you want what kind of character do you want? What kind of number do you want? Do you want a big int? Do you want a small int? Do you want a tiny int? Tiny int is 0 to 255 or negative 127 to 128. Things like that. I actually recently ran into a problem because I was actually helping a client do a Facebook application. And Facebook has made their user IDs just part of their regular object ID namespace, which means that their user IDs can be 64 bits. So we have to store them in big ints, not in regular ints. Now, this kind of honks me off because an unsigned int, the range goes from 0 to 4 billion. So to me, if you have more than 4 billion users on your thing, congratulations, okay? That's wonderful, because there's only like 7 or 8 billion people, or you've got like half the people in the entire world on your, on your thing.
That's not counting those aliens.
All the bots that create accounts, right? So now I'm talking instead of actually looking at the manual, which is, silly, but okay. I'm running this meeting, so I can do whatever the heck I want. You can't stop me. You can only eat pizza and walk out. I edit the video, by the yeah, exactly. Darn, she fell for it.
She's gonna do both.
She just eat pizza and walk out. All right.
She's gonna drink Diet Coke.
Exactly. Okay, so now this is behind here. No, go back. There we go. Ha ha. Fooled you. Data types. Look, data type overview, numeric types, date and time types, string types, data type storage requirements. This is pretty important. So again, why would I care if I have to use a big int? Well, if you scroll down here, right, big int takes 8 bytes. 8 bytes! That's double an int. That's 4 bytes. I mean, if you have 1 million records, that's 4 million extra bytes, man. That's like 4 megs of extra data, okay? It's just a thing with me. I don't know. But anyway, it's just one of those things that you don't have to have it that way, right? If you have, if you have something where you're doing like a sports thing and you're doing all the teams or something, or it's like number of departments in your tiny company, tiny int, unsigned, 255 values, or 254, that's probably enough. Or no, it's 255. That's probably enough. But look at the values and figure out what you actually need or what's reasonable. Because you don't want to have to change it all the time. You don't want to ever have to change it. But you also don't want so much overhead because you've got these huge things, I mean, if you wanted that, you could just make every column, a text column and be done with it. And the whole point is to be, better than putting it all in, like, strings in a text file. So now, if there were any justice in the world, I'd be able to do that and get back to super little things in life, I'm telling you. Yeah?
Before you move on to the entity diagram, what do you think of the visual modeling tools available for those diagrams?
What do I think of the visual modeling tools available for doing things like ER diagrams so they come out looking pretty like this? I think they're great. The problem is that they don't do this kind of modeling. Even though they say they do logical modeling, pretty much what they end up doing is physical modeling. Because I have never, ever seen a diagram generated that looks like this. There are always some data types in there. See, ER diagrams, they don't have data types in there because it doesn't matter. Okay? It doesn't matter that language is a string. It really doesn't. Well, that's a bad example because that's an entity. But it doesn't matter that cost is a decimal. Nobody cares. It's the cost of it. You're just talking about the relationships between things. You don't care what the attributes of those things are. You care about the relationships and the entities and the attributes. So, I think they're good tools. I mean, did you want me to talk about certain tools?
No, you don't have to. I'm just curious.
I think they're useful, but for me, I pretty much find it, because I haven't really gotten into the whole GUI side of things, I pretty much find it's really helpful for me to write out a schema and then reverse engineer it in the program so that I get the picture. Because to me, it's actually more informative for me to go to the actual schema creation, like, show create table or the actual definition, than the picture. Oh, the picture's pretty useful with the little arrows.
I like the schema creation tools too.
So we have actors here, and an actor is an entity. And the attributes of the entity are first and last. So now what we have is we have an actor stars in a movie, right? The movie has a stars actor. So this is now the relationship between actor and movie. And if we ever decided that we wanted, who's the president of their fan club or whatever, we can now put that as an attribute of actor. So now their first name, their last name. Groucho wants to change his last name. He got married to Stella Marks, and so now he's going to change it to Groucho Marx. And so now he can change his last name, and then we don't have to worry about updating every single movie. We update one entry. We update the one actor entry. That's him, and it's still associated with the same movies. Similarly, we have the category. We have movies classified as category, and we actually have languages, right? Now, this is something that is also interesting because we had original language and the current language. So if I had a movie that I'm watching and it's in English, but it was originally in French and it's dubbed, right? The languages are the same. English is the same. American English is the same as, American, like ENUS, right? FR is French, right? So however we decided to represent language, and I didn't actually put any attributes of language, but I would probably have like a name of the language. Or I might have the name of the language in the country it's spoken in, because English in the UK is different from English in the US. So I don't actually have that here because, as you can see, the diagram got pretty big. But you can imagine that, off over here, there's a little, line to a circle, and inside the circle, it says country, and then there's another one. But there's still some things like, rating, feature, again, title, description, year released. Those still are attributes. Now, could we make rating an entity in and of itself? Sure, if the Motion Picture Association of America decides that, now it's not rated X, it's rated NC-17, which they've done, right? They've changed the ratings. Now we would have to go through every movie and change the whatever. But, again, there's no one right year diagram. We could do it with year released, right? But that's kind of silly. You're never going to change a year, right? But you might have, in a different application, you might have a need to actually just reference the year because you don't want the redundant data. Maybe it's a lot of data. Maybe it's not the year, maybe it's, somebody's, a date or something that would be a lot bigger than just representing the year.
Star Wars original release renewed.
Yeah, exactly. George Lucas went back in time and changed stuff. So yeah, I pointed that out already. So now, it's only now that we're ready to create tables, right? And you're going, oh my God, it's 7:30. We've been talking a half an hour. We haven't even created a table yet. We haven't done anything. Well, we've done a lot. So for now, I'm going to just say one table per entity. Now, I said before that you don't have to think that there's, one entity per table kind of thing. But first, you have to talk about the data types. Chapter 9 of the MySQL 5.0 manual is data types. I'll bring that up now because if I was smart, I would have had that prepared. But I'm not, so I didn't. And this is just things like, do you want what kind of character do you want? What kind of number do you want? Do you want a big int? Do you want a small int? Do you want a tiny int? Tiny int is 0 to 255 or negative 127 to 128. Things like that. I actually recently ran into a problem because I was actually helping a client do a Facebook application. And Facebook has made their user IDs just part of their regular object ID namespace, which means that their user IDs can be 64 bits. So we have to store them in big ints, not in regular ints. Now, this kind of honks me off because an unsigned int, the range goes from 0 to 4 billion. So to me, if you have more than 4 billion users on your thing, congratulations, okay? That's wonderful, because there's only like 7 or 8 billion people, or you've got like half the people in the entire world on your, on your thing.
That's not counting those aliens.
All the bots that create accounts, right? Data types. Look, data type overview, numeric types, date and time types, string types, data type storage requirements. This is pretty important. So again, why would I care if I have to use a big int? Well, if you scroll down here, right, big int takes 8 bytes. 8 bytes! That's double an int. That's 4 bytes. I mean, if you have 1 million records, that's 4 million extra bytes, man. That's like 4 megs of extra data, okay? It's just a thing with me. I don't know. But anyway, it's just one of those things that you don't have to have it that way, right? If you have, if you have something where you're doing like a sports thing and you're doing all the teams or something, or it's like number of departments in your tiny company, tiny int, unsigned, 255 values, or 254, that's probably enough. Or no, it's 255. That's probably enough. But look at the values and figure out what you actually need, or what's reasonable. Because you don't want to have to change it all the time. You don't want to ever have to change it. But you also don't want so much overhead because you've got these huge things, I mean, if you wanted that, you could just make every column, a text column and be done with it. And the whole point is to be, better than putting it all in, like, strings in a text file. So now, if there were any justice in the world, I'd be able to do that and get that super little things in life, I'm telling you. Yeah?
Before you move on to the entity diagram, what do you think of the visual modeling tools available for diagrams?
What do I think of the visual modeling tools available for doing things like ER diagrams so they come out looking pretty like this? I think they're great. The problem is they don't do this kind of modeling. Even though they say they do logical modeling, pretty much what they end up doing is physical modeling. Because I have never ever seen a diagram generated that looks like this. There are always some data types in there. See, ER diagrams, they don't have data types in there because it doesn't matter. Okay? It doesn't matter that language is a string. It really doesn't. Well, that's a bad example because that's an ND. But it doesn't matter that cost is a decimal. Nobody cares. It's the cost of it. You're just talking about the relationships between things. You don't care what the attributes of those things are. You care about the relationships and the entities and the attributes. So I think they're good tools. I mean, did you want me to talk about certain tools?
No, you don't have to. I'm just curious.
I think they're useful, but for me, I pretty much find it, because I haven't really gotten into the whole GUI side of things, I pretty much find it's really helpful for me to write out a schema and then reverse engineer it in the program so that I get the picture. Because to me, it's actually more informative for me to go to the actual schema creation, like, show create table or the actual definition, than the picture. Oh, the picture's pretty useful with the little arrows.
I like the schema creation tools too.
Well, see, that's the thing, is that I don't do that, because then you spend so much, it's like a PowerPoint diagram, right? You spend so much time playing with it and getting it just right, and then you click like schema create and it doesn't do what you want. It's like, well, I know how to schema create. I can, I don't have to worry about what kind of arrow it is, so that when I click schema create, it's going to do a foreign key. I can just do the foreign key and then it'll do the arrow right.
On a good tool, after you actually laid out your schema in it, you could actually produce the SQL to create the database file.
Right, but you're talking about laying out a schema. You're not talking about laying out an entity and a relationship.
Right.
And that's why I kind of don't want to say, like, well, it's one entity per table. That's what I'm saying for now. But I really want to make sure that people understand that that's not the way it is. For instance, the movies and the actors, I mean, that might be 3 tables, right? Because you might have a table with like the actor ID of like 4, and then it would have the name, and then it might have even another table with like their address or their email address or something, because they might have 7 email addresses you can reach them at. So I really, or their studio that they just last worked with, if they have a contract with them. I don't want to get into too much thinking of that, and that's why I showed you the slide over here, where, category could be an attribute, but it could still be a separate table. There's no reason that says that it can't be a separate table if it's like that. So, the diagram doesn't necessarily translate into a schema, and so my beef with the modeling tools is that they're not really modeling entity relationship diagrams. They're modeling, like, the schema. So, but they say, oh, it's a logical model. Maybe I haven't used the right things, but I've used some of the higher end stuff and they don't do that, so. That's just my little rant. But then again, I have a rant about like data types and big ints when space is cheap. So, what can you do? But again, it's important though. And it's not just important because it's the principle of the thing. I have friends who worked with me, so that's why he's laughing. It's important because if you're doing something like you say, okay, I want to use MySQL cluster. That's a great storage engine. Guess what? You really have to count all those bytes, because if you've got 1 million rows and you've got, if your indexes have over, 32 bytes, now you have to add another 8 bytes of overhead to the 25 bytes of overhead that are already there. Now, I was working with it today, which is why these numbers are stuck in my head. But, that's really going to make a difference when you're working with cluster. That's really important. So, you might say, well, who cares? But it can make a difference. It can make a difference when you're joining tables. When we found out this thing about the Facebook app, the developers were talking to me, and they're like, well, do we have to change it? Do we have to have like a lookup table? I'm like, no, we'll just use a big int. I'm just kind of, like, I'm kind of sore about it, but for this application, we can just use a big int. So it's not even like you're going to be struck down and your database is going to have really horrible performance if you use big ints, or if you use characters even instead of like numbers. But it does have a performance hit. So, there you go. So, we talk about data types. Do you want bigger, smaller? What are you doing if you're joining on things? Text takes up more space than numbers. You know, numbers converted to binary versus, because it's all bits at the end, it's all zeros and ones, so if you're converting, you know, the number 7 to zeros and ones, it takes a lot less space than the letter A. That's just how it works. So if we've got some arbitrary string data, and right here on my little notes. So we've got some arbitrary string data, like the movie title, the description, right? So they don't just have, like a rating, I could say, that's probably maximum 5 characters, right? PG-13 is 4 characters, right? So I could say, okay, that's a pretty small, you know, data length to have. That might be its own entity, right? The rating. We didn't do that in this diagram. So we have some string data. We have the movie title, the description, the first name, the last name. So there's documentation on the string types. So I guess I'll have to go there since I'm showing it to you here. Go back here. So here's chapter 9, data types. Here's string types. And you've got car, var car. So car is just characters. You know, if you say car 5, it's going to be 5 characters. If you have multi-byte characters, then that's not 5 bytes. That's 5 characters, right? So that could be different. You could have up to like 3 or 4 times the space used for that. So again, while UTF-8 is great, you know, you don't want to necessarily use something that's going to make characters bigger than they already are. If you know you're using a Latin 1 ASCII set, then use it. I wonder if I can make this bigger, since everyone's kind of squinting. Oh, look at that. Look at that. Now you can see things. So car and var car, they're not really that big of a deal. Car just has leading spaces, and trailing spaces are removed. Var car actually removes trailing spaces also, so you have to be careful if you know you're going to have something with some trailing spaces. Var car values here are not padded when they are stored, because car values are, because they're more of a fixed width thing. But they also have some overhead because the var car needs to know how long it is. So this is kind of a, you know, silly example where they're giving you this, you know, here's the value is nothing. With car 4, it's 4 bytes. With var car 4, it's 1 byte. It should be 0 bytes, but it has to have 1 byte to say there are no bytes in here. So here, you know, there's 2 characters. It's 2 characters. It's a car 4, so it's still going to be stored in 4 bytes, right? It's 4 bytes all the way. And it even truncates this, probably silently, because that's what MySQL does. Whereas here in varchar 4, right, it's got 3 bytes for this, because it's got 2 bytes for A and B, and then 1 byte to say it's 2 bytes long. Similarly here, now it's 5 bytes. So if you're doing something like an MD5 hash, you know, it's a password field and you're doing a hash, and it's always going to be, you know, 32 characters, don't use varchar, use car. If it's always going to be similar, you know, don't use the maximum. Like, if you know the maximum is 10, it probably behooves you to do a varchar of like 12, because you're going to use 11 anyway, so give yourself that extra leeway, because you're not really using it. So, yeah, so this last value here, that's actually going to be applied, and you're going to get a silent, people might call that a silent failure. It's a silent success, but it's a failure because it didn't tell you, it didn't warn you or anything. I mean, it might give you a warning. If you're using strict mode, it will actually, which is SQL mode equals strict. If you're using strict mode, then you'll actually get an error, which is, might be what you want. And really, I mean, there's some interface behind this that probably should give an error long before it ever gets to the database. But one of the other things that I really wanted to show you was there's 2 places that I like to see things, not just the size of things, but also, I mean, there's 2 different ways of size. There's how many bytes does it take, and then there's how long can you have it. So like text uses whatever the length is plus 2 bytes, so long as the length is 2 to the 16 bytes. Anyone know offhand how many characters that is?
65,000.
Thank you, 65536. So if you have more than 65K, you want something bigger than text. Similarly, right, tiny text is 2 to the 8th, which is 120, no, it's 256 or 255, right? Because it's L plus 1, so you can't have more than 255 because you need that 1 byte for overhead, and it takes 2 to the 8th bytes. So, if you know that you're going to have something between, 0 characters and, I don't know, a description, right? It's not going to be somebody's personal bio, because that's probably going to be more than 255 characters. But like a description of, this field is used to do something, or, maybe it's text that goes along with an object in your application. Probably tiny text is enough. And again, how many bytes is it going to use? You don't want to be using, a long text, because even if you could say, well, it's only using like the length plus a few bytes. But if you use long text, it's using the length plus 4 bytes. So if you're using long text figuring, okay, I'm just going to be covered for every single possible value, well, you are, but if every single possible value is pretty much going to fall in the range of 10 to 15 characters, you have 3 more bytes of overhead than you would have had you just used varchar or tiny text. So yeah. Anyone else want to, comment on my rants? Tell me I'm nuts and crazy. You can say that to the end. So,
we don't want it preserved on video that we send you.
Well, I'll edit that out. After I find where you live and hunt you down and shoot you. So I'm going to define some strings. The movie title and the description, and in fact, that's what these were in the last thing. These were just, let's keep in mind the movie title and the description. The description I'm going to do is text because, again, a plot synopsis might be more than 255 characters. Title, probably not more than 255 characters. It's really hard to get more than 255 characters on the side of that box, You might have a subtitle that's longer. 255 characters is a lot of text for a title. Not a lot of text for a description. For actors' names, varchar 45, not null. Last name, varchar 45, not null. I just actually looked at the existing data set and said, okay, tell me what the approximate length of data is. If you have some data, that would, work. If you're dealing with things like first names and last names, you can go to some online site that has lists of names, maybe it's donations or something, and, it's semi-random. Last names, if people hyphenate, might be more than 45, so...
And if you're using not null, what if you get someone, I'm just thinking of like, you get like a famous actor like Sting. Is that his first name or his last name? And then if it's not null, how do you...
Well, that's an excellent point, right? Madonna, right?
Yeah.
Or Cher, who's actually been in movies. Well,
Yes.
Madonna's been in movies,
Yeah.
too. I can't think of a movie Sting's been in.
Dune?
So, well, Madonna has a last name. But anyway...
The bad news.
The Bad Dune was, Sting was in The Bad Dune.
The Bad Dune.
With Kyle MacLachlan, yeah.
Exactly.
But yeah, I mean, that's the only thing I could just think of is like maybe a not null. I'm like, I don't even know if that's his first or his last name.
Right. The other question is, why do we have first and last name here? Are we ever really going to be looking for someone? Like, we might sort by last name. Are we ever really going to sort by first name? Like, maybe this is a personal collection. We're like, oh man, Reese, what's her last name? Oh, let me just look at everyone who starts with R. Probably doing something like having last name, comma, first name, or even just last name, first name. So just, Sinatra, Groucho, or whatever. And that way, you can look up by last name if you really want to alphabetize by last name. But do you really need 2 attributes for name? In this case, probably not. Right? That's another, right?
Yeah.
Why did I automatically put first name and last name? Well, that's what's in the Sequila sample database. But, these are things to think about. Like, my mantra is think. Don't blindly do what I did and just pick first names and last names just because you're used to, because then there's middle names and whatever, and what if somebody has like 4 middle names? Are you now going to do like a table that has multiple? Forget it. So in this case, that's a great thing. And Sting, right, is a great example of somebody that doesn't have a first or last name. And I put not null, so here I'm requiring first and last names. Now you can say, well, you can just put the empty string into like the last name, put the first name. But again, for this data set, because there are people who have 1 name and no last name, it's probably better to just have 1 name. Because again, do we ever really need to look for people with a certain first name? Probably not. Unless we're playing that game, that game where you're like, the first name and the last name of people and you try to connect them together, but that's not what this is for. So, I have some not nulls here, and I've circled space apparently. So the description could be not null. Could be null, excuse me. But the title is not null. Because there has to be a title for the movie. I will not accept a blank title for a movie. And if so, then it's probably blank, right? It might have weird characters, might have numbers, 1984, whatever. I'm not putting any constraints, but I'm saying there has to be, it can't be null. There have to be characters, even if the character is empty string. Right? The description can be null. It defaults to null. Now, why would you want null as opposed to, blank? Well, sometimes you don't know the description. If you don't know the description, it might be null. If you know that there exists a description, but there is none, right? The description is blank, then you want blank. This doesn't really translate to this particular description thing because usually movies have a description, but if you're going with like the official studio release description, you probably want to know the difference between I don't know what the studio release description is and there is no studio release description. Null and blank mean different things. On the other hand, there can be issues with null, especially when talking numeric data or timestamp data and stuff. So you want to take those into account. And it also, some operations are slower with nulls in the table than not. Some operations can't use metadata, like my ISOM tables and stuff. Can't always use the metadata if you specify things with nullable things. So pretty much it's usually pretty good to try to avoid nulls if you can. But if there are situations where you really want null, then use null. Don't use 0 or blank to mean null unless there are no real values for 0 or null, or 0 or blank, excuse me. I could rant for longer, but I'm not gonna. And again, we already went into the description of what happens when you have someone with no last name. So numeric data. So some of the numeric data we had are length in minutes, the cost in US dollars, and the year released. So there are numeric types that we can use. Now the year released, I could use a year. The benefit of using the year is if we actually went to, I'm not going to bore you by going to manual pages because you can do that on your exciting Saturday nights going to read the manual pages, right? So year released, you might say, well, that could just be a number, 4 digits, right? Well, if you store it as a year, it actually stores it in 2 bytes instead of 4. So that's not too bad. If you ever do it as a 4-character string, I will rant at you. Enough said. It'll just be slower, you can't compare things, harder to compare what's less than what. MySQL will implicitly change the types of things for you, but don't put things as a string that really don't need to be a string. I will find you. Cost is going to be some kind of decimal. If the cost is going to be in US dollars, probably don't need more than 2 decimal points, maybe 3 if you're doing rounding and stuff, but not for a cost of something. But if you're doing financial stuff, you might need more. If you're doing things in, Mexican dollars, you need different amounts. If you're doing things in yen, I mean, do I need to specify that something's going to cost more than $1,000 for a movie? Not unless I'm a collector, So, but it might be more, it might be 1,000 lira or something, going to, old Italian currency that doesn't exist anymore. So you really have to think about, what you're doing. If you're making a global application, apply it globally right away. That being said, you're going to end up something with like a 22-digit number that has like 10 decimal places because of all the different kinds of currencies and stuff. So, try to give yourself some slack and some, be reasonable to yourself. If you think you're going to go to euros right away, Canadian dollars, again, you probably will need 2 or 3 decimal points. So numeric data defined, I picked small int 5 for the length of minutes because I figured it might go over 255 minutes. It's probably not going to go, a few orders of magnitude more than that. Cost in US dollars, cost decimal 4,2. So decimal takes 2 numbers. The first number is the total number of digits that are in it. The second number is the number of decimal places. this does not make sense to me, and every time I do it, I have to go look it up, because inevitably I do something like 2, 2, because I want 2 numbers before the decimal point, 2 numbers after the decimal point. So, I screw up all the time, but there you have it. 4 digits, 2 of them are decimal points. 2 of them are after the decimal place, excuse me. Year released, I picked the year format, because again, it's smaller, it does what it needs to do. There's actually a book that I was reading called Practical Issues in Database Management, which when I edit this video I will put a link to in the thing that I do. And it actually talks about having specialized data types. So things like years, right? Or take something like an age. You don't really add ages, right? You don't really add years. You're not going to add 2004 to 2006. You might add 2 years, you might subtract them, but you're not going to, like, you might add a number to years, right? How many, what is it going to be 10 years from now, or in 2018? I'm going to add 10 to 2008. But it doesn't make sense to add 2 years, right? And it doesn't even make sense to add 2 ages, unless you're saying, what's their combined experience in something. That's not really ages, like what's their combined experience on Earth, maybe, but again, you might be talking about years in that case, but not ages. So, the book, makes for like, certain date, if you really, the best database in the world would be one that was so strongly typed that it would have all these specialized things where, you would never be able to add 2 years because you never want to add them. It's interesting to have constraints on the data. I don't know how far I'd go with that. But it is an interesting concept because, again, you could probably specialize things more, much like year is specialized because, it's only a certain range. Yeah, all right. Any questions? If I lost anyone? Is everyone going, I wish I could just grab some more pizza right now, and I wish you'd stop talking. Get some pizza, have some so again, here, I've defaulted the length to null. Because it's, probably 0, a length of 0, I'm probably never going to see. And you know what? I don't want a length of 0 there. Because if I'm doing a count of how many, items have lengths or whatever, I want that not to be counted. Okay, I don't want to be counted as having a length of 0. Now you'll also notice, which I didn't circle, that it's unsigned. That means there's no sign. What's a sign? A negative, right? You're never going to have a negative length, right? It'd be really cool if you could. You watch it, you go back in time. Awesome. I'd watch that all the time. Oh, I need like 3 more days to finish this project.
I've had movies where I wish I could do that after I saw it.
Yeah, those wouldn't be going on the shelf though.
Maybe
Not your
frisbees.
Yeah. So yeah, similarly, I think I could have done decimal unsigned, and I probably should have, because nobody's going to pay me to give me a movie, probably, right? Year release, you don't have to specify signed or unsigned. It knows it's a year, and there are no signs for years. But yeah, default null for that, default null for the year. Are you ever going to have a year released of 0? Julius Caesar didn't watch any movies, okay? Super. At least none that are recorded on some kind of format that we can still read them today.
Didn't record Jesus of Nazareth when it happened?
Cave paint, running really fast past cave paintings doesn't count. I'm in a mood today. Oh my god. That doesn't count. So, besides running really fast past cave paintings, they didn't have them back then. So, so there's a point somewhere in there. Oh, you're never going to have a year of 0. Year's going to be null, right? If you don't know what the year is, it's not 0, it's null. And you can't have blank with a numeric type.
Could you have, I know you say it wouldn't be no. Will year not take a negative, like if you wanted like a before Christ type of thing of like when certain historical things happened, this happened minus 2000? That, I'm just curious.
That is a great question, and the answer is in the manual. As I tell people, I use my brain for processing, not for storage.
Yeah.
So I'm always going for the manual. And as you can see, I'm a complete geek, database geek, because I say things like, I use my brain for CPU, not for storage. Mm-hmm. So
And that's why she wants the data types to be smaller, because she can memorize more stuff.
exactly. Thank
She
you.
clusters her brain. No, I agree. I mean, if you could just get like the administrations of most educational institutions to be like, why do they make you memorize practically everything? Like, here, memorize this formula.
Because
If I could do it,
test that way.
that is easier to test, but is that really what we're?
Is there a point to the test?
Well, I mean, my whole argument is that most classes want you to just memorize things, and if you can't memorize like the difference, you know, the factorization of the difference of two cubes, then you know you can't do that later on. But if you had the book, like if I worked at a job, I'm not gonna sit there and go, you know, I was gonna figure out the trajectory of that rocket, but I can't because I don't have the book. I'm just gonna guess and get it wrong. I'm like, no, I'm gonna get somebody. I'm gonna look it up in a book.
And if you guess and get it right, then why should you get the points, right?
Yeah, I mean, just like.
Well, let
Something's-
me ask you something. In real life, do you get credit for doing something right because you understood it, or do you get credit because you do something right? Sadly, a bumbling idiot who makes a fortune in the stock market, right?
Yeah.
Or you even do that. You even see that with sports. There's always some upset, and whoever's winning the football pool is always like somebody who just like circled
Yeah.
whatever and like the
$10,
Giants. So that's
yeah.
who she picked for the win the World Series, right? Nobody would pick the Giants, right?
Well, I get picked by my favorite cities. I've seen that.
Exactly.
Come on, in the 90s,
And they
people-
win. They
people
win.
fumble in the stock market.
Exactly. So there's always some component of whatever, which is
Yeah.
a shame. It would be great if, you know, everyone kind of got.
But my agreement with you is it's like I can do it. I remember how to do it. I may not remember everything about doing it. I can look it up. What good is it if that information is not there to be looked up? I probably can't do it anyway. So yeah.
Hey, as long as you keep agreeing with me, I'm happy, right?
There you go.
So the year type. The year is a 1 byte type. This makes me extremely happy. This is better than a coupon, okay? 1 byte! 4 digits in 1 byte. Very exciting. It's a 1 byte type used for representing years. It can be declared as year 2 or year 4 to specify a display width of 2 or 4. Display width, not storage width. This is the same actually as numeric types. You might see int 10 or int 2. And if you say int, as opposed to a small int actually has, you know, a 5 next to it by default. If you say small int 4, it doesn't take 4 bytes to store that number. It still takes 5 bytes. What it's going to do is it's going to pad that number to 4 digits. Or it's going to contract that. Well, it's not going to contract the number, but anyway. Year 2 or year 4 is a display width. That's all it is. Still takes 1 byte to store it. It doesn't take any more bytes to store year 4. So you pretty much always want to store it as year 4, unless you really have some kind of tiny application that can't actually read the data and get it like that. For 4-digit format, it's YYY format with a range of 1901 to 2155. So, yeah, Jesus didn't make any movies. Sorry.
Okay.
For 2-digit format, you can have from 70, which is 1970, to 69, 2069. Why does it matter? Why can't it just be any 100-year range, 70 to 69? Because if you do things like compare it to now, it's going to actually compare, you know, 1970. You know, you say, well, what if I want it to be 2070 to 2169? You're going to have to wait a couple of years for that. Or, you know, to change the data types. You can also specify, let's see, when you input it, you can specify it as a string or as a number. You know, you said what happens if you enter a negative number. You can't, right? Here's how you can actually input it as a string, and it will implicitly cast it to that year number, because it knows it's going into that thing. And you can also do it as the result of a function that returns a value that is acceptable in a year context, such as now. So if I give it now, which is 2008-02-11 space 20:04 whatever the seconds are, it's just going to say, okay, if she's putting that into a year column, it's 2008. It's pretty smart. Smarter than me in some ways.
Well, as long as the time on the server is correct. Because it grabs now.
It grabs now, right? But hopefully the time on the server is correct enough to the year.
Yeah.
And if not, get a new server.
Well, or run NTV.
Run NTV. Yeah.
Run NTV. Blah, blah, blah. Note that the range for two-digit numbers is slightly different from the range for two-digit strings. So two-digit number in the range 1 to 99. Values in the range 1 to 69 and 7099 are converted to 2000 to 1970. You can't spy 0 directly as a number and have it be interpreted as 2000. You have to specify it as a string because when things return false, they return 0. So MySQL doesn't want to do, again, MySQL doesn't want to do this whole null is 0, 0 is null thing. If you specify 0, it's going to think it's null. So you have to actually specify it as quote 0 or quote 00. Or it has to actually be interpreted as the number 0000. So you have to be really explicit when you're making the year 00. Again, I would always do it as 4 byte year. But again, obviously year is very specialized, as you can see. So if we were doing, for most applications, you might actually want to use 4-digit number. You might actually want to use a date, which is month, day, year, or it's actually year, month, day. But, again, it's my application, and when I say my application, I mean I just used whatever MySQL used in their sample database, so. Oh, hey, look, we're back at the beginning. Choices. So what happens when you have a choice? Like the NPAA rating. You have to have exactly one of them defined. Okay, maybe you could have null because you don't know what the rating is, but it's on the back of every single box. Just like the title. It's always there.
Unless you get the unrated version.
Well, then we'll have an unrated. Because again, you want to know the difference between unrated and non-rated. Right? Non-rated, if it wasn't rated at all, that's null. But unrated is a special, because unrated doesn't mean that it has not been rated. It means it's rated up so high that you don't want your kids to watch it.
Yeah.
When they say special unrated version, they don't mean this was never shown to the Motion Picture Association of America, so they never gave it a rating. So, hey, have anyone watch it. Doesn't really matter. What they really mean is
It's extra spicy.
it's extra spicy, right? Exactly.
Depending on what movies you get, you can get unrated versions that haven't been shown.
You can get them, yes.
No,
So, and
legally, but-
again, you want the difference between unrated and non-rated, right? So here,
Form fills.
for the purposes of this discussion, because that's the data set that I found as a kilo data type thing. I didn't make these examples, I'm just using them, okay? How else am I going to show that the year data type if I don't put years in it, Alright, MPA rating must have exactly one defined. The DVD special features can be 1 or more. Don't ask me why it's not 0 or more, but each and every single one of them has 1 or more. Now, well, you can have 0 or more. So enum, I don't know if people know, do people know what enum and set? So enum is the choice of 1. You have to have 1, and you can have null in the enum. It's an enumeration, which enum is the abbreviation for enumeration. Then you can also have a set, which is actually 0 or more. Maybe I'll change that slide, maybe I won't. Probably not, because I'm lazy. But if we go back here and take that away, look at that. So the enum is a string object. The value chosen from a list of allowed values that are enumerated explicitly in the column specification at table creation time. This means that if you want to change the list of values, you are going to have to alter the table, which might be fine if you're using a set of data like the MPA ratings that don't change very often. However, if you're using it for types of users you have, you're probably going to find that the kinds of users you have are not just going to always be paid and unpaid, right? You're going to have paid, unpaid, didn't pay me when they were supposed to, paid half. Maybe you have different levels or whatever. You might start out with free and paid, and then you might go to different levels. So when you're thinking about data types, you also want to think about how am I going to change this? One of the benefits of enum is that it is stored as a number, a very small number. because it's one in a set. So value number 1 might be the word paid, and it looks like the word paid in the database. So really, it's the number 1. And you know me, I get all hot and bothered with smaller data types. So you would think I'd be really excited about this. Again, when you need to alter the table to change it, that's not so exciting because now you have 10 minutes of downtime while you have to update every single row because the alter table statement's going. So, so here's how it's actually done. Create table sizes, name, enum, small, medium, large, things like that. One way that you can get this kind of functionality without having to do an enum and being able to do that is to have a foreign key to a table. But instead of having a numeric foreign key, just have a string foreign key, right? So you can say, instead of having the name be an enum, small, medium, large, have it be a character field, maybe varchar 10 or something, or 7, 2, 4, 6, medium is 6 letters long, small and large are 5 letters long. But maybe you're going to change it because you're going to have extra small, extra large, extra medium. So maybe 15. And then you have that be the foreign key, but to avoid lookups, just have the foreign key be the actual string instead of a numeric lookup and then whatever. So then the only time you're actually having that overhead of the lookup for the string is when you're inserting or updating the row. It works in some cases, in others you have a high rate application and maybe you're not reading so much, so you want to make sure that that you're doing stuff all right. So you can't have variables, you can't have functions. I'm not going to go through that. A set you can have one or more of. Now the limitations are with enum you can only have 256. So they would work for countries of the world, but again, countries of the world, that changes every so often. Every couple of years you get a new country or some old country disbands and forms 7 new countries. And states in the US, that's been pretty okay for now, but what happens when you go with the first 50 states, then you realize, oh wait, I want Guam in there and Puerto Rico and all the territories and whatever. So things like that, lookup tables are better. You probably also want a lookup table for something like that because you might want to sort based on that, or you might want to have reporting based on that. So you might want to do a left join with the table because you might want to see that there are 0 people in Massachusetts. Right, so if you had that as an enum column, that'd be a lot harder to extract that kind of data. If you just have a table, you can do a left join. The set type is a string object that can have 0 or more values, each of which is chosen from a list. Now, what I wanted to say in my brain, that I don't think I actually got around to saying, was that enum can have a maximum of 256 values from a list. I did say that. I remember saying that now. Set can only have a maximum of 64 possible values. Because it does all of the, you could have all of the possible permutations and combinations of those 64. So set is pretty useful when you want a set of different things, but I can't put all of the actors in there, all the distinct actors in the database into a set, which would be great, because then I can say, okay, well, it's this actor and that actor, and you just take it from a set, and again, it's in a very small number of things. So the data itself is not the strings. It's numbers, so it's compressed. But you can only have 64. So, yeah, see, MySQL stores set values numerically with the low order bit of the stored value corresponding to the first set member. And again, for both set and enum, it doesn't do anything like alphabetize it automatically for you. The first value that you do in the create table definition, or in the column creation definition, that's the first value. That's value number 1. It doesn't matter if it begins with Z or if it begins with Q or A. So that's another kind of annoying thing when you're altering a table to add something. It can be really handy if you're doing a lot of populating pull-down lists or something. Just say, well, show me the create table definition and get everything from that and put that in the pull-down list, as opposed to select distinct, which would take forever. But then you have to alphabetize it and. So yeah, this is showing if you have set A, B, C, D, then A is 1, B is 2, C is 4, and D is 8. Which is why you can only have 64. Because now you can do some addition, so what happens if you have A and B, you're going to have 0, 0, 1, 1. What happens if you have the set A, comma C? You're going to have 0, 1, 0, 1. Yay, binary. So set and enum are not widely used because they're kind of very specialized, and to change them, you need to do an alter table, and again, if you're going to have 7 million records in the table, you probably don't want to do that. So there are definitely good applications for it, but they're probably not the ones that you think, oh yeah, no, I want to choose from a list, so I'm going to do that. So here are the choices that we have. G, PG, PG-13, R, and NC-17. Default is G. I might put unrated in there, but again, we're only going with American movies. And then their DVD special features are, any one of the set of trailers, commentaries, deleted scenes, and behind the scenes. But you can also have null, right? And this is another really good case where blank is not null. There is no such thing as the DVD special feature blank. It has a name. If it doesn't have any, then it doesn't have any, and it's null. And again, just because that's the way it is logically, doesn't mean that you might not realize, hey, we really need to use blank instead of null, because even though from a purist, standpoint, we mean null, we really just need to use blank because it's really going to screw up the performance of our queries. That's acceptable. I'm okay with that. But you got to start with the purist and then go from there and say, okay, we're going to break from this because, like specifically have a reason. And not because that's just the way somebody told me to do it years ago. Even if that person was me.
You sure about that?
I'm sure about it because I want people to know, because then in 10 years when I turn around and say, images are great to put in a database, don't go back, but you said they weren't. And then I'm screwed. So again, we've defaulted to G, we have default null. So, do you want a choice or do you want an arbitrary string when you're doing these things? Again, it's up to you, it's up to the application that you're doing. For category and for language, what do you think? Should we have a choice or should we just have a string?
Let's say a choice.
You'd say a choice, like an
Well,
enum?
because you might get some people, if you have an arbitrary string, you could just start getting people typing the same thing. If they type something slightly different, if it's a choice, then you're forced to choose, and you could always add something.
Okay.
If the language wasn't there, and the language could be added, but if you just type whatever, you might be like, oh, I typed English, but they spelled it slightly wrong, or they typed something, and it's like, okay, now there's another entry, but it's not. I don't know, that's.
All right. Anyone else have anything to say on the subject?
You have a lookup table for the language.
Well, that's what I'm saying. It's like if it's a choice from a table, you start with English and you can add languages.
I'm specifically talking about choice as in enum or set
okay.
versus arbitrary string type like car, var, car.
Oh, okay.
Arbitrary string being it's a string, but it's not a set number of right? It's not either one from a list as an enum or one or zero or more from a set, which is set. So are you saying basically arbitrary string have a lookup table?
That's how I was thinking of it.
All right. Well, stop. You're both right. We'll have a category. We'll have tables, right? So now it's not both, right? Because we're actually using arbitrary string. We're just having it in the same function as enum or set because we're having a lookup table. So we're going to create tables for the category and for the language. And we have car 20 for the language because I guess they didn't really use. I would use the ANSI standard 5. Character long, like EN_US. It has 2 digits for the language, and then an underscore, and then 2 digits for the country, using the ISO country. I guess it's ISO language standard. It's using the ISO country codes. So BR_BR. No, P. It's Portuguese. PT. PT_BR is Brazilian Portuguese versus PT_PT, which is mainland Portugal Portuguese. And they're very, very different. Very, very different. And as someone who was recently in Canada for 3 weeks and picked up a book in UK English to read, it's very different. I could read it, but I was like, that's every page, I'm like, that's a neat expression, that's a neat idiom, that's a neat way to say that, so they're different. But Brazilian Portuguese and Portugal Portuguese are alike. Yeah? Anyone want to say anything before I actually made a joke and made people laugh for a little bit? Yeah, okay. Oh no, I did car 20 too. Look at that. I don't know why I did car 20. Probably because it's what they did in the kilo sample database. Next time we talk about inserts and selects. Look at, oh my god, it's 8:20. I've only babbled for like a little over an hour. This is unheard of for this. Does anybody have questions or comments? I know I went through really basic stuff. But that's what I promised, so can't get mad at me for not being super geeky. Well, you can, because I did actually put in my little rants and stuff about super geeky in this. So, anybody have any questions or any, what would you do in this case, or what about that, or hey, let's map out a schema, an ER diagram for something. Nobody really wants to fulfill my deep fantasies by like sketching out ER diagrams. I'm really disappointed in all of you.
Do that all day long, we gotta take a break from that.
Oh, you use modeling software. Are you really doing editing relationship diagrams, Fred?
No.
Not really.
He
That's
was like,
okay.
I saw him scratching one on a napkin during lunch,
Yeah.
The condiments related to this, and
Since I can't really even read my own writing, I have to use tools.
Yeah. I mean, and the question is really, what's the value of having an entity relationship diagram instead of the schema, right? Because the schema is really important, right? The developers need to know what tables to look at, stuff like that. Well, the thing is, when, and not if, when your application grows organically like they all do, you want to be able to go back to that model and say, this is what the movie, the movie has this relationship with the actor. Even if now the actor is like a whole different database, it doesn't matter. Here's the original relationships, okay? Now we've added some other, actors are married to other actors, so that would be a little dime. Look, I'm doing it on my own. You guys wouldn't let me sketch out my own, so now I'm making stuff up to make my own. But that would be like a diamond from actor with an arrow back to itself, right? Because actors could be married to other actors. So again, you might have this whole like soap opera database of actors and what they've all done with each other, but in terms of marriage and having like Drew Barrymore came from Barrymore's and famous actors.
And that's called OK Magazine.
Exactly. Exactly. But they don't do ER diagrams either.
I think that using the UML, some of the products will indeed do what you're trying to do. The trouble is, learning the UML is a challenge in itself.
Learning the UML is a challenge in and of itself, and most people don't have this stuff as a model. I mean, I learned ER diagrams when I was doing like theory, when I was, at a liberal arts college doing computer science theory. I also learned relational algebra and relational calculus, which, okay, what good does that do? Well, again, it doesn't do a lot of good when you're just like, okay, let me just code this. But when you're really getting into like the deeper aspects of things and you want to make sure that you're going to be able to scale and you're going to be able to do this, you need those underlying concepts. As a system administrator, I could care less about bootstrapping, okay? But the one day your computer doesn't turn on, you want that heavy theoretical knowledge of bootstrapping so you could say, well, if I stick something in the floppy drive, why doesn't it work? Well, because it hasn't gotten to the place where it loads the driver for the floppy disk yet. That's why, so there are other things you could try. Something in the CD-ROM drive maybe, or go to the BIOS and make it so that it loads those drivers first. And if it's the drivers that are bad, then you're screwed. But you could take the disk drive out and put it to a motherboard that already has, whatever. Anyway, somewhere in there was a point, and I hope you understood the point, because I probably didn't. So,
We'll dig it out.
Exactly. The point being that the diagram is useful for a modeling purpose. Even if the actual reality doesn't look anything like the model, you still want the model because you still want to know where the original thoughts came from, where the original plans came from. And just because the model doesn't immediately translate to what you have in actuality doesn't mean that it's not valuable even to add on to. And you shouldn't necessarily change your model to fit what you already have because, again, those relationships are still there. When you get into something like, okay, now we need a data warehouse, you're going to pick different dimensions on which to model your data. And I use the word dimension on purpose because that's a data warehousing term, right? A movie might be its own dimension. And that dimension might actually have the category and the rating and whatever. You might denormalize all that into one table. And that's perfectly acceptable. That, that would be like the simple ER diagram we had at the beginning, where there was only one attribute and it was a movie and it had all the things in it. That might be what you would use in a data warehouse. And it's really valuable to be able to go back to your ER diagrams and say, okay, in this application of these entities and these relationships and these, the way these interact in the natural world, how are we going to represent that here when we need a high transactional thing? How are we going to represent that here when we need a lot of reporting, a lot of analysis? Alrighty, super. Anything else? Any questions, comments?
Your opinion on Sun's purchase of MySQL?
My opinion on Sun's purchase of MySQL. Some people say, well, Sun was dying. I don't think they were dying. They were perhaps making less in profit than they had been in the previous decade or two, but they're far from being off the map. This does give them another edge into another foray into a different world they were not in before. They have some people developing Postgres, but they don't own Postgres.
Yeah, that's what some of the mailing lists that I was reading about. They were like, what's that going to happen with development of Postgres at Sun? Is it going to trail off? Isn't it? Are they going to drop it?
Well, there's about a dozen people that work, and I think only about half of them are full-time, that work for Sun developing Postgres. There's still community development of Postgres. Yeah. There's currently about 400 people at Sun from Sun's purchase of MySQL that work on MySQL. Who cares about the 12 people? There's like 30,000 employees at Sun. You think they're going to care about 12 people? I mean, is the U.S. recession unit that bad that 12 people's dropping? And I mean, it has its own purpose and value. I mean, Postgres is not the only, well, not the only thing, but it's very dissimilar to MySQL. It's more similar to Oracle it's more of like a free Oracle than it is like a,
Postgres community strong enough that if the Sun did drop its support on it, does it still continue on?
The question is is the Postgres community strong enough that if Sun dropped, like fired the 12 people working on it, or they worked on different things, right, would Postgres still be viable, still be developed on? Yeah. It would be a lot different for MySQL. MySQL has, a commitment to have different versions come out every so often, and they have a calendar and all that kind of stuff, but they have 400 employees. If MySQL had 12 employees, you would see smaller, fewer releases and that kind of stuff. But MySQL also has a lot farther to go in terms of features. Postgres already had them. When I was doing that theoretical learning, I was actually using Postgres because when I was learning about how databases work, MySQL didn't have subqueries. Kind of hard to model out what a subquery is when you can't actually see it in action in a database. So MySQL has kind of a lot more features to be written into it. Postgres is kind of now at the point where, it might be adding, I mean, it is still adding some features and things, but it's also more adding things to go on top of Postgres. This is all my opinion. No real knowledge. I'll just pontificate for a while. But you asked me to, so it's all right. It would probably get a little slower. I mean, if Josh Berkus stopped developing Postgres, then yeah. But I mean, I don't think Josh Berkus would stop developing Postgres, and I don't think he could. I think he likes it too much. I mean, if Brian Aker left MySQL, do you think he would stop developing MySQL? No. It just wouldn't happen. So, I mean, I think that the people that are committed to it are very lucky in that they get paid for doing what they love.
If I get to talk to Brian at the right group of drivers, I'll have to ask him what his personal plans would be.
Brian, I think, has his fingers enough pots. I mean, given his work with Memecached, given his work with Tangent.org, given a bunch of the other stuff he's done and written, I think that he probably wouldn't have to work if he didn't want to, but he does because he loves what he does. So again, I mean, there's a lot you couldn't pay me to do, and I mean, you couldn't pay me enough to work as an Excel spreadsheet monkey. I love databases. I love doing databases. If I didn't work, if I was a spreadsheet monkey, or if I was, spreading tar on roofs, I'd be coming home and working on MySQL.
I had a hard time convincing a lot of people that Excel spreadsheets weren't databases.
Exactly. But again, I mean, if I wasn't working on databases, if I was, doing something else, I would come home and I'd work on databases. So, yeah, I think less development would get done if Sun decided we're not going to pay for Postgres development, but it would still get done because the people that are developing on it aren't developing it because it's their jobs. They're happy to have their jobs developing it because they love developing.
It doesn't hurt to get paid to do what you love.
Right.
Yeah.
Right. So yeah.
But you love even more.
And yeah, they have conferences that are put on by the community. So, that to me says the community is pretty darn strong.
Well,
So, yeah.
Sometimes indeed a community can outlive its sponsors, so to speak. I see that happening with Foxborough, for instance. Microsoft is dropping this development in Foxborough, where they're going to make the code available to the community. There is a large community that's been built up over the years around Foxborough. The problem with keep it going, just as long as those people want to develop it.
Hey, there's plenty of companies that still use IBM mainframes, right? Because, hey, why fix it if it's not broken, right? Same thing with Foxborough. Or Lotus Notes. Not that I see IBM giving that up anytime soon, but, man, there are people who, die-hard Lotus Notes people, still die-hard Lotus Notes people, they wouldn't sell their soul for anything else. Because
They
it's
already
just,
sold it to get notes.
don't tell them that.
How many souls do you have to sell, right?
They wouldn't get extra souls. Like if you gave them extra souls, they wouldn't take. So people like what they like. That's why people go, oh, it's the end of Microsoft. There are way too many people who love Outlook and integrated everything. But there just are. And that's why when Oracle bought EnoDB and people are like, oh my God, it's the end of EnoDB. Like, oh my God, it's code. It's
Well, Microsoft has had to change their tune in some areas. You notice that you do research, they have a lot of training aids that are now available free on their products that used to charge for.
They're doing that a lot because the trend is open source. So they're putting like, oh, we're trendy too. We have some open source things, but it's not the same.
So I think it's more that they want people groomed in their products.
Well, they want
Embrace,
to.
extend, extinguish.
They want to give free trials so that you'll be hooked, and then the first hit is free, and then I don't know. So as for the Sun MySQL deal, I think it's wonderful. I think it's wonderful from both sides. I think it's great. It was a huge surprise to me because I was like, I just heard them talking about going IPO, and now somebody bought them. Like, whoa. Sun has a pretty good commitment to community. If anybody here went, I know a couple people here went to the New England Database Day that was sponsored by the New England Database Society. Well, the New England Database Society, in turn, is sponsored by Sun Microsystems. So, we of the MySQL, piddling 400-person company about to go IPO, we have pizza and soda. If you go to the New England Database Society, they've got like wine and cheese, and they they do. They actually do. So anyway, I think it can only be a good thing from my perspective. I don't think I don't think like, oh, Oracle should be quaking in their boots. Not really. Oracle's a different product. It's still a database, but it's a totally different product.
It'd be interesting to know if they actually have a vision of what they want to do with MySQL.
Yeah, I bet they do have a vision. I think what they want to do is make it part of their product line. I don't think that they have a vision like, ooh, if we only bought MySQL, we could, make replication not suck so much. I don't think that Sun really had that idea in mind. I think that it's really, I don't think they have a strategic vision for the product. I think they might have a strategic vision for the company.
Also, if it works really well on Solaris, it's one of those things. It was like, LAMP is Linux. You could run it on Solaris, and if they worked a lot of stuff in there, so there's a lot of good stuff, like working some of the dtrace probes into MySQL, so that you can analyze things better.
Yeah, that would be great. That would be awesome. And honestly, if they work things, you might say, well, what if they're only going to concentrate on Solaris? Well, they're not going to.
Yeah.
Because no problem. They haven't done that with Java. They haven't made Java Solaris only. So why would they make MySQL Solaris only? Especially if this started out being, on every
Yeah.
platform. But I mean, if they get multi-threading working in Solaris, come on, how much of a stretch is that to get it working in Linux?
Exactly.
Not that much. So it's a win. I think it's a win on all sides. $1 billion is a lot of money. And that's probably one of the reasons that MySQL went for it instead of going IPO. Then again, they did make a $1 million deal, so it's probably not too out there to say, hey, they're worth 1,000 times more than their biggest deal. And when you buy it forever and ever and ever. It's not like a license that you have to buy every year, So
Like Oracle.
like Oracle, much like Oracle.
Yep, we boned you last year. We're going to do it again. We need more money from you.